know what all of these statements are and how to write them, okay? The first couple are just asking you to write a conditional statement. So we just have to rewrite it in if-then form. When it says to mark the hypothesis and the conclusion, the hypothesis is the if part, the conclusion is the then part. So however you want to mark it, like on the quiz, we asked you to like underline it and circle it, or you could just say H and C for hypothesis and conclusion, but we want you to identify the hypothesis and the conclusion. You may have to rearrange the words a little bit, like we've talked about, to make it make sense. We don't just want to say if two right angles, then supplementary. That doesn't make a whole lot of sense. So try to make it make sense when you rewrite that if-then statement. When you get down to numbers 2 and 3, they give you the P and the Q statement, okay? When I write the conditional, I'm going to simply say if this, then this, right? That's my conditional statement. Converse, we are going to flip it. The two statements flip. If this, then this. The inverse, we put not in the conditional, and the contrapositive, we put not in the converse. Okay, what I'll tell you about biconditional. Biconditional can only be written if the conditional and the converse are true. Okay, so if one of these two is false, then this would not be a statement that I could write. So there is a possibility that you may not have to write a biconditional. Okay, so that's why you want to look at this first of all and determine if they are both true. So it doesn't say to find the truth value, but you do need to find the truth value in order to determine if a biconditional would make sense or not. So you got two of those problems. I know it's a lot of writing, but that kind of preps you for how to write those out tomorrow for the test. Okay, on number 4, when you give me a counterexample, that does not have to be in a sentence, right? It doesn't have to be in if-then form. I just need something that proves that statement to be false. So if I look at the second one, for instance, all numbers end in 4. What does it mean to be divisible? It will divide evenly, okay? So if I try to divide something by 4, that means I don't get a decimal or a fraction. And the number has to end in 4, okay? So numbers that end in 4 would be like 14, 24, 34, 44, okay? So does 24 divide by 4 evenly? Yes. Yeah, so 24 is not a counterexample. 24 proves this one true. What about 14? It does not divide evenly. So 14 would be a counterexample. So the only thing you have to do there is just give me an example of something that makes it false, okay? And there's lots of, in most cases, there's a lot of things that would make that true. Would be counterexamples, I should say. Okay, I know that on the quiz, we really struggled with the law of detachment and the law of syllogism. Okay, when I do the law of detachment, this has to happen first. I must have a right angle. If I have a right angle, then I know its measure is 90. If I said angle B is 90 degrees, I can't say angle B is a right angle, okay? Based on the law of detachment. I know in most cases that we would say, yeah, that's true, but this has to restate the hypothesis. We can only go off of what we are given, okay? If this is restated, then this is my conclusion. Angle B is 90 degrees, okay? But if I restate the conclusion, then I can't make a statement, okay? So the hypothesis must be restated. Remember on the law of syllogism, we need a conclusion and a hypothesis to match up. If these two match up, which they do, then my new statement would be, if a figure is a rhombus, then it has two pairs of opposite sides that are parallel. Number 7, just kind of describe to me what a vertical angle is. That's what we talked about yesterday. Good luck. Number 8, we did some problems like this yesterday. Remember, because these are vertical angles, these two are vertical, these two are vertical, so we're going to set the vertical angles equal to one another, and then solve for x and y. And that's what this is asking me. Solve for x, solve for y. So you're going to have an answer of x equals whatever and then y equals whatever. Okay, I wrote it over here so you kind of have an idea. There's 7 problems on the review that you need to write as a 2-column proof. This one doesn't say write it as a 2-column proof. It just says solve the equation, justify each step. But I would write it as a 2-column proof because I think it's easier to set it up that way. So I would start off with the given equation, okay, and say given. And then I'm just going to start solving it step by step. And 9 and 10 are very similar, except just a little bit different equation. Okay, let's take a look at number 11. I'm going to do number 11 with you because I think this one's a little bit tricky, okay? There's a couple of different things on here that are a little bit different. We talked about this when we did it. But in this case, this is another 2-column proof. It doesn't say to write it as a 2-column proof, but anytime it says justify or describe what's going on, then I think you probably should do a 2-column proof. So for, bless you. Number 1, I'm going to restate the given statement. Hey, up here, it says that we are going to solve it for L. That means we're trying to get L by itself. So here's my equation. We're trying to solve for L. What would I do first? Okay. We got to get rid of the W, right? So we're going to subtract 2W. And when I write that out, I think that kind of helps me to identify what my step was or what my property is. Because we subtracted 2 from both sides, then that's just the subtraction property of equality. Okay, we still don't have L by itself yet, so we got to do one more step. What do we got to do to get L by itself here? Now we're going to divide. So we're going to divide by 2 on both sides. And that would be the division property. Okay, so that's the first part to this problem. Solve for L. We did that, okay? Now they're asking us to go a little bit further. And it says, if I have a rectangle that has a perimeter of 32 and a width of 5, I want to find out what the length is. That's why we did this step here first, because now I have L all by itself, right? And I can solve for L. If I know P and I know W, I can find L. So we're going to plug 32 in for P, 5 in for W. 32 minus 2 times 5 over 2 equals L. Make sure you do order of operations here. So I did multiplication first. Now, here, it gets a little bit tricky maybe, but when I do order of operations, I would typically say multiplication and division comes before addition and subtraction. But because we have subtraction on top of the fraction here, I got to do the subtraction first in this case. So I got to subtract 32 minus 10 and then divide. So the first step is to solve for L. Once you have that, then we want to find out what that length is. Okay, you can plug it in.
Do you have to justify the length or just the part?
Just the equation part, yeah. But what the reason I did that one with you is I don't want you to plug the numbers in at the very beginning, okay? If we plug in the numbers at the very beginning, then I think that's going to be a little bit confusing for you. and you're gonna try to figure out what am I doing here. So don't plug in the numbers until you have L by itself, and then you can plug it in. Okay, now I'm not gonna go through this whole next one with you, but this next one is very similar, except they don't give you any numbers. And this one, we are solving it for B, getting B by itself. What operation is assumed to be between the 1/2, the B, and the H? Multiplication, okay? So I had a lot of people last hour were asking me about this, so I want to go ahead and talk about this. One way I could get rid of the 1/2, because this is multiplication, is I could divide by 1/2, right? But dividing by 1/2 gets kind of messy. So what would be better than dividing by 1/2? Multiplying by its reciprocal. Multiplying by 2. Okay, so what I would probably prefer here, and I think you guys would probably agree, multiplying by 2 is a lot easier than dividing by 1/2. Dividing by 1/2 gets a little bit messy in how to write that. So this would become 2a. The reason this works is because if I take 2 times 1/2, that really just becomes 1, and I don't even need to put the 1 there, it just becomes bh left. And now I can solve for H, solve for B, and get rid of the H. And the rest of it shouldn't be too bad. Okay, 13, all you're doing on these is just naming the property. We've done several of those matching sheets. Hopefully you still have those, bless you. Go back and look at those properties, know those properties. There's not going to be any properties on the board tomorrow, okay? You've got to know them all, and we've talked about a ton of them. So make sure you know your properties. Try to do these proofs on your own, okay? I'm just going to tell you straight up, like when I post my answers, whether it was to the proof packet yesterday or to the review tonight, then, you know, in years past, what I always see somebody will do is I see them have their computer open and they're just like staring at my work and they're staring at my proof, right? That is not a way to learn how to do proofs, guys, okay? I'm just telling you right now. If you just look at me and say, oh yeah, I see what Mr. Ruda did here. That makes sense to me. And then when you get the test tomorrow, you're going to be like, I have no idea how to do this, okay? The only way to practice doing proofs is to do them, okay? And then use my key that I post to check it to see how you did, okay? But you've got to make sure that you're practicing it. If you're not practicing it, you're going to really struggle when it gets tomorrow because we haven't done proofs before. This is a new topic, something new we've never done. And so you've got to practice it, okay? Some of these proofs are very similar to ones that we've done before. So go back and look at your proof packet if you need help. Or look at other proofs that we've done in our notes if you need help. Most of these should be similar to something that we've already done. Typically, we're not going to give you something on the test that we haven't covered in the chapter, right? And so use that to kind of help you out. Okay, I'm going to help you get started on number 16 here. And then I'm going to let you finish it out. But just kind of help you get going on this one. Complete the 2-column proof, okay? Not all of these said to do a 2-column proof on, but these are the ones that I would write a 2-column proof for. 9, 10, 11, 12, 14, 15, 16, okay? Just because it helps to kind of organize your statements and your reasonings and everything else, those are the ones that I would set up as a 2-column proof. Easier for me to grade, easier for you to set up. So it should be easier for both of us. Okay, given statement, angle ABD is a right angle. Okay, what does that mean? If I tell you ABD is a right angle, what do we know about ABD? Yeah, it's 90 degrees. Good. So I'm going to say angle ABD is 90 degrees. And how do we know that? Definition of right angle. You bet. All right angles are 90 degrees. That's another thing you could say. You could say definition of a right angle, all right angles are 90 degrees. There's a lot of different things that you could say there that would work, okay? But just something that we know that all right angles are 90 degrees. Now, and I kind of wanted to set this one up because somebody was asking me about this one last hour and they were trying to set these two equal to one another. Does it look like these two could be equal to one another? Maybe, right? But we don't have any markings saying that these two are equal, so we cannot set them equal to each other unless they tell me that they're equal, okay? Do not assume they're equal, and if they don't say that they're equal, they're probably not equal, okay? So don't go off of what it looks like, go off of what we know. And what do I know about these two angles together? They equal 90, right? So this angle plus this angle equals 90. Now, before I plug in the expression, here's what we're going to do. We're going to say angle ABC plus angle CBD equals angle ABD. And that is the angle addition postulate. Philip. Yep, I'll let him know. You bet. Oh, you're supposed to go see Mr. Patton. He said, take your stuff. Oh. All right. Okay, so that's the angle addition postulate, okay? At this point, once we know that those two angles add up to equal the big angle, now we can start substituting in, okay? So we're gonna put this in for ABC, we're gonna put this in for CBD, and then ABD. What do we know about ABD? It's 90, so 90 would go in for angle ABD. So just plug that in, that would be substitution property, and now we're going. Now we can solve the equation out. And remember, our goal is to get to the point where x equals 12. Okay. All right, any questions about any of those so far? Okay, I'm gonna let you guys work. If you have questions, feel free to